Okay, so here is our question. We have 5 different random variables. Okay, suppose those random variables are x1, x2, x3, x4, and x5. Okay, and they are drawn from a population with mean expectation of xi's or each mu and variance sigma squared. Okay, so we have 5 random variables, and each has a mean mu and variance sigma square. They're from the same population. And we are suggested 3 different estimators, okay, for the mean of the population, mu. All right, so we're trying to estimate a population parameter, which is mu. So the question is, which estimator would you prefer? Okay, so in order to find which estimator we should prefer, we have to look at first whether those estimators are unbiased or biased estimators, right? So you remember this. So in order to do this, we have to first calculate the expectation, okay, of the first first estimator, mu1 hat, okay, which is given by expectation of x1, right, which is mu, right, because it's our given. Okay, it's in the question. So it's mu. So therefore, we have a mean of the estimator is equal to population mean. So therefore, it is unbiased. Okay, unbiased estimator. Okay, so this is unbiased. How about second estimator, mu2 hat? If you look at it carefully, what's the expected value of this? Expectation of x1 plus 2x2 x5 over 2. And as you can simply, because expectation is linear operator, this would give us 3 mu over 2. Okay, which is not equal to the population mean. Therefore, this is a biased estimator. Okay, biased estimator. How about the third estimator, which is mu3 hat? Okay, what's the expected value? The expectation of x1 plus x2 plus x3 plus x4 plus x5 over 5. And what's the result of this? Because its expectation is linear, so you can basically write them expectation of x1 plus expectation of x2, expectation of x3, expectation x4, expectation xy, which are all mu. So it's going to give you 5 mu over 5, which is equal to mu, okay? Which is also equal to population parameter mu. So therefore, this equality is hold, and we conclude that it's unbiased estimator. Okay? So we have 2 unbiased estimators, which is mu1 and mu1 hat and mu3 hat. There are 2 of these estimators are unbiased. So which one would you prefer? Well, there are 2 of them. Of course, the one with the smaller variance, right? What's the variance of mu1 hat? The variance of mu1 hat is the variance of x1, right? Which is sigma squared. Okay, it's pretty simple. How about variance of mu3 hat? Okay, that is to say variance of x1 plus x2 plus x3 plus x4 plus x5 over 5. Okay? Alright? So we know that this constant, okay, which is in front of everyone, right? And variances, again, can be treated as linear operator. However, this constant has to be squared, right? Remember, the variance of, if you have a random variable y, which is ax, and the variance of y then is given by a squared variance of x, right? Remember this relationship? So from here, we can conclude that the variance of x plus x2 plus x3 plus x4 plus x5 over 5 is given by 5 variance sigma squared for each one of them divided by 25, okay? Because it's squared. So which means these cancel each other out. This is going to be sigma squared over 5. So compare this variance with these variance, okay, of the first estimator. But the third estimator, okay, has variance sigma squared over 5, which is less than sigma squared. So therefore, the final conclusion is that the mu3 hat is preferable.